actually build a better accessible way. So, just a quick intro to me. My name is Stow. I'm a Stow everywhere online, so you can quickly do live. I've been doing this 15 plus years. I'm currently the senior UX engineer for the National Rugby League in Australia. So I make sure I know myself from the design process all the way to the finished product. So, W3C state that they think people should get access to the web, regardless of the software they use, the computer we have, the language we speak, regardless of our sensory interaction modes. But unfortunately, what most of us do is do it for this guy and her. So just two beautiful, intelligent, young, able-bodied people with perfect sight who can afford high-end laptops and smartphones and yet use them at the same time. And that makes it insane. But it's not what we need. So why is accessibility so important? According to the World Health Organization, more than 1 billion people, 15%, have a long-term disability. And that doesn't include lesser disabilities that also impact users. Now 15% is more than your Firefox and Internet Explorer users. So bear that in mind. Of these, over 50% find the web to be challenging to use, and almost a third recently said that the web is becoming less accessible, generally due to single-page applications. As we continue to live longer and longer, disability rates are growing, with up to 50% of 65 and over having a disability. And we need to remember that people with disability is the only minority group that anyone can join at any time. A few years ago, my dad had a cycling accident, suffered traumatic brain injury. A few weeks ago, my brother-in-law just lost all feeling in his left side, was having diagnosed with multiple sclerosis. So, if I can help these people to use the web when they are incapacitated, as they did before, then I will do. Luckily, equal access is often required by law. In Australia, we kind of lead the world. Since 2010, all websites have to be accessible. Now, it's not kind of punished as much as it should be, but there have been some big lawsuits against big companies such as supermarkets and things like that. In the US, Section 508 is their accessibility laws, and that declares that all federal websites must provide comparable access for people with disabilities. And in December last year, the European Union ruled that by 2018, all public sector websites must be accessible as well. So we're starting to realize that we can't penalize people because of their ill health. So what types of disabilities do we care for? There's four main groups: people with hearing impairments, cognitive and learning disabilities, mobility and physical impairments, and vision disabilities. So I'll go through each one of these. So hearing impairments obviously affect people with full or partial hearing loss. Some quick wins we can do for these, maybe not development quick wins, but we can provide captions and or transcripts or audio and video, which also benefits non-native speakers, and also benefits people with what we call situational disabilities. So you're a parent trying to continue to watch a video while nursing a sleeping baby. The second group is people with cognitive and learning disabilities. So anyone who has a kind of brain disorder or injury, such as people with attention deficit disorder, autism, dementia, the list goes on. For people with dyslexia especially, we should make sure we use the Song Serif font for body copy. It's a lot easier to read, we should avoid justified text, and writing things in all caps. Everyone can benefit if we simplify the language used and the amount of content that's used, and also if we reduce the complexity of the user interface. Simpler things are simpler to use for everyone. Animation and transitions when done nicely and tastefully, can actually help users understand the context shifting of things that happen. But animation should be invisible. It shouldn't be this thing that jumps out at you. It should just be this thing that's subtle to guide the user, to let them know that something just happened. So Apple actually learned this the hard way with iOS 7 all those years ago when they revamped. It was full of animation and people were actually getting physical motion sick from it. With each release since, they've been turning back the animation. Safari 10.1 was just released, which actually introduced a new media query called prefers reduced motion. So if you have a system preference on Mac, you can actually, as developers, we can reduce the amount of animation or change the styles accordingly for those users. So it'll be interesting to see how that takes off. The third group is for people with mobility and physical impairments of their upper limbs. So for people who still use a mouse, we need to make sure that the mouse is kind of forgiving. Touch targets need to be big enough, and we all struggle with mega menus. You scroll, you go down, and you don't quite follow the right path, and you select the wrong item. So imagine how much more difficult that'd be if you've got Parkinson's disease or your, hand tremors or whatever. It's a lot more effort just to try and do those fine motor controls. Because most assistive technologies use the keyboard in some manner, we need to make the keyboard a first-class input device, as well as touch and mouse. So we need to ensure that everything can be tabbed to, interactive elements, that there's a sensible tabbing order to them, and that everything then has a visible focus. So vision disabilities is the last group, and it's split into people with colour blindness and people with low or no vision. So the poster chart that everyone is associated with disability, we need to put alt attributes on content images, which is obviously correct. We also need to make sure that just because there may not be text that's visually there, it needs to be there for people who can't see the screen. So it can give them some context of where they are. We also need to make sure that the palette that you use has a suitable color contrast ratio. So there are three main types of color blindness, 2 red-greens and 1 blue-yellow. Now, males are genetically more susceptible to color blindness. At any one time, there may be up to 10% of your users affected, which means that you can't rely on color alone to convey information. Hence why the default link style is underlined by default, and then it goes underlined disappears on the bottom. As an example, last year, Anthony Nolan did a survey on the state of front-end tooling. I'm sure some of you completed it. And when I was looking through the results, it instantly occurred to me that these charts weren't actually very colorblind friendly. So if you suffer with either of the red-greens, it's even worse in this particular, but you can see that you can barely make out the ones on the side, you can't really differentiate them, and even that one over there. So both types of red-green suffer with that same issue. Now this could have been resolved really simply by just adding the legend label next to the percentage as well. And then you would know which one was expert, which one was advanced, etc. If you use Trello, they rely on colours a lot for their labels with cards. At some point, they obviously realised that most of those colours were indistinguishable for lots of people. So they added a colourblind training mode, which adds patterns to the colours as well. I'm not colourblind, but I actually use this because I find it's easier for me to recognise which colours I'm seeing. But if you're not colourblind, how do you simulate colourblindness? If your design team still use Photoshop, you can simulate 2 red-greens within it. Color Oracle is a good cross-platform app which simulates all 3. You'll just change your screen at any one time. No Coffee is a really good Chrome extension which can simulate even more color blindness modes, as well as lots of other visual deficiencies with range sliders, and you can test lots of things. And then there's ACSS SAS mixing, which basically allows you to, you can add it into your bundle in a debug bundle, and you can target specific selectors and elements and that kind of stuff, and say, I want this to render as a particular red-green colorblind mode, and see how it looks. Now, obviously there's going to be varying degrees of colorblindness, so it's hard to simulate perfectly. And all of these have slightly different results, but you can use them at different points in the process. So your designers can use them, and then you can, I guess, make sure that the designs are still accessible as you go through the build process. For the color contrast ratio, text needs to be a ratio of 3 to 4.5 to 1, depending on its size. And you don't need to know how to work out the ratios. I don't know. There are tools for that for us, such as the very nicely named mycolors.com. You also need to make sure that the ratio isn't too high. Unfortunately, there aren't any guidelines of what is too high. Direct black and direct white is, because it can also cause additional kind of blurring and jumping around for people with certain conditions. Testing in grayscale is also quite useful, because that can highlight various color contrast issues as well. So I'll just show you how my colors test all works. So I just put in black text on a red background, and then change the lightness slider up. And you can tell it reports to me straight away at what font sizes it fails at, what my actual ratio is, and it gives me the resultant text code as well, so I can put it back in my color palette. So what tools do the vision impaired use? People with low vision may use screen magnifiers, which are built into the OS, and browser zoom. And people with low and no vision will use screen readers such as JAWS and NVDA on Windows and VoiceOver on Mac and iOS. The screen readers hopefully announce where you are on the screen and what you're doing, where you are on the page, etc. So, in a recent screen reader survey from last year, 85% of screen reader users use Windows, and almost 50% use it with IE. So when you do your testing, that platform combination has to be part of it. If you don't have access to a Windows box, Microsoft provide free VMs, which will help you to do so. And iOS is the dominant platform for the vision impaired, so it's important that you test VoiceOver on that as well. So, as well as announcing where you are on the page and what you're doing, screen readers give quick shortcut access to the landmarks of the page, headings, lists and links, and jump to and use form controls, that kind of stuff. They can also connect with Braille displays, which is really cool, so it can physically print the bumps for you as it reads it, and a lot more. If you're on Mac, in system preferences, there is VoiceOver training built into it. I recommend that everyone do this because you will learn a lot about how people actually use assistive technologies. So now we know what we have to cater for. How do we build for accessibility? So, in my opinion, it's a three-step process. The first is to follow the Web Content Accessibility Guidelines, or WCAG for short. The second is to use semantic HTML, but to understand how CSS also impacts the rendering of assistive technologies. And the third is to implement ARIA, often with JavaScript. It used to be thought that JavaScript made things inaccessible. You pretty much need JavaScript to make modern things accessible. So I represent it like this hierarchy of accessibility. WCAG is this nice foundation with principles of how we actually build things. And we use plain old semantic HTML, good quality HTML with a core to get things right. And then we layer on top ARIA to make more difficult and, I guess, complex components and widgets. So what is WCAG? It's a W3 standard from December 2008 that's showing its age, but it also shows how well it actually performs. It recommends how to make content accessible for people with disabilities. It's generic, so it doesn't actually dictate any technology choices, unlike the previous version 1, which was a nightmare to develop. You have to develop government websites in Australia in the 2000s. It's divided into 12 major guidelines across 4 principles, and these are then divided into sub-guidelines with success criteria and have a performance rating from A to AAA depending on the level of complexity. Interestingly, the first draft of version 2.1 was released in February, which is looking to add another 60 success criteria, and it's hoping to deal with things like modern mobile devices, the issues that they've brought about, and other things to do with low vision. But there's already been some pushback from the accessibility community. Lots of us just don't believe that some of the things are achievable, or they're not testable, or some of them are actually contradictory to what already exists. So we'll have to see how that goes as well. So the first principle of WCAG is that people need to be able to use the interface in ways that they can perceive. So the key word here is perceive, not see, not hear, however they can actually absorb the content. So discuss earlier about we need to provide text alternatives and captions and make sure the color contrast is okay. Also need to make sure that the relationships between elements are conveyed to people who can't see it. The second principle is to make it operable for everyone. Primarily, we need to make sure this means making it work with the keyboard. So, out of the box, the browser gives us scrolling up and down with cursor keys. As developers, we often break this. We need to stop doing that. Tab and Shift tab should be able to move back and forth through controls and enter in space to actually click and select things. We need to give users enough time to read content, and they need to be able to pause and stop things that are moving. So it's just another reason not to use a carousel, because nobody wants to put a pause button. And we need to help users to navigate and find content. So pages need to be titled properly, and the purpose of links and buttons need to be explicit from their actual button text so they can be read out of context and understood. They can't just say click here because that's meaningless. A user needs to know what this button is going to do when it's pressed. Principle 3 is making it understandable. So again, we need to make the text at a useful kind of same language level that everyone can understand, which is about a high school level really. And we need to make the content appear in predictable ways. So as you navigate through the site, components need to be in the same position, that kind of stuff. And I'll talk about door slamming modals. Things shouldn't happen unless a user actually causes the interaction. You can't shift the user's context without them doing anything. And the last principle is to make it robust, to maximize compatibility with current and any future technologies. So our only basis of doing this is to use proper valid HTML. If we get that right, it's much more future-proof. So that leads me into the second part of the hierarchy. So using semantic HTML. We should add a valid and relevant lang attribute to the document. This gives screen reader users the correct voice profile to use and accent, but it also helps with things such as like Google Translate. We should never disable zooming. Just because you think you can read the content okay, doesn't mean the next person will be able to. Some people may wish to be able to zoom into images. Some people may find copy and pasting really hard on mobile, so zooming in is useful there. 2.1 of the WCAG draft is actually suggesting that we need to support up to 400% zoom on mobile. So we're going to have to test in those circumstances. And if you use position fixed, be aware that that can often obscure content in Zoom. We need to use the appropriate HTML elements. HTML5 added lots of new semantic things such as main for the main content, asides, that kind of stuff. But there's also classics such as field set to group related form elements together. And no, I does not mean icon. It means a tag. And we shouldn't skip heading levels. And this is a lot easier said than done, especially in a modern kind of component architecture way that we build things. But it's the primary way for users to understand the hierarchy of the page. Unfortunately, the HTML5 outline algorithm is a myth. We cannot just nest sections of H1s to create a hierarchy. It was never implemented. It looks like it never will be implemented. So we just need to use the correct sequential order of headings. If you need to visually change an appearance of a semantic heading, you can use the utility path to do so. And we should use native browse controls where possible. They have accessibility already built into them. Designers love to reinvent the select box. We need to push back on that, because trying to recreate one accessibly is hard work. And in general, only links and buttons should be clickable. Angular, for whatever reason, decided that ARIA was a thing and let developers add ng clicks to anything. And everything was okay, but it wasn't. Because just because you try and recreate existing functionality badly with JavaScript doesn't make it okay. 2 elements should be clickable. And all form elements must be labeled. Whether you can visually see that label or not, an input without a label is meaningless to the user. They won't know why they jumped into it. And placeholders are not labels. So to understand the impact that CSS has, my first suggestion is to test without CSS. When I build things, I build them just the raw markup first. I get the semantics right. I try and understand the relationships between the elements. Because it's too easy to recreate visual design and just put pieces together without understanding how it all fits together. We need to use an appropriate minimum font size. 14 pixels minimum, 16 if possible, which is why it's the browser problem. And you need to be aware that pseudo content is read out. So it needs to either be meaningful or empty. So if you do use icon fonts, make sure that it's not being read out as some weird Unicode character. Sighted users don't always need additional information to see relationships. So it's okay to use the visually hidden class to hide content from these users, but it has to be this specific one which is accessible and keeps it accessible to assistive technologies. Like display none, visibility hidden hides assistive technologies, but it can be animated. So you can still transition your collapsible panels nicely and have the content then hidden from users. And you shouldn't remove focus outline, or if you do, you at least need to provide alternatives. So I recognize that focus outlines can be ugly, and they're not always required for touch and mouse users, because things like toggle buttons, if you just click a state, you don't want to see a big blue halo on it. So I actually wrote a small little library called keyboard focus. All it generally does is checks to see if the user pressed the tab key. If it does, it adds a class of keyboard focus. And then with that, you can style a specific focus element style just for that. You can also use it, I guess, if you have things that would normally appear only on hover, such as pencil edit icons at the end of a table or something like that, which if they were there all the time for sighted users, there'd be too much visual noise. In future, we should hopefully be able to use the focus ring pseudo class. So this is a new proposal, and the browser will decide for us whether it thinks it needs to render a focus outline or not. So the last part of the hierarchy is ARIA. So ARIA is a spec from March 2014 by the W3C to help increase the accessibility of rich internet applications. So the W3C realized that the web is becoming less of a document format and more application one. So they needed a way to be able to allow assistive technologies to understand how things were kind of happening and being interacted with. So it uses roles, either they're implicit in the element, or we can assign them with attributes to describe the type of element. And it uses property attributes to describe relationships, functions, and UI states. So there are 81 roles in total, split between landmarks and widgets. These are the ones that are commonly used. So landmarks, I said screen readers can jump directly to landmarks. So it's important that you tell them what the search is, what the navigation is, what the main content is, so they can jump directly to that thing. Widgets, you probably use alert quite a bit, I imagine, dialogues if you do modals, and tabs and the various tab related ones as well. ARIA properties, there are 40 plus of those. Some are states, which are mainly true or false, on or off kind of stuff. Some are kind of constants. ARIA current is new in, actually it's the new version of 1.1 of the ARIA spec. It's in draft, it's actually been implemented, so it's recommended we use it. And it's actually introduced ARIA current, so we can finally tell a user that this item in this navigation is for the current page. We've never been able to do that before. We have things like ARIA label and ARIA label by, which allow us to override or add new text, accessible text to people with assistive technologies. Sometimes when you build things, your CSS and markup just don't allow a normal parent-child relationship for whatever reason. ARIA allows us to define this. So, some useful examples of putting all this together. So a hamburger menu. We all know what this is. We all know how it works. Okay, we can see it. You click a button, the menu opens, you can click links. But if you couldn't see that, how would you know that those links relate to that button? How would you know that that button was open? That kind of stuff. So we start off with our good markup. So we use the nav element to tell us the navigation. Also, I've added the role of navigation just to make it more explicit that this is what it is. I've given it an ARIA label of main, so it will be read out the main navigation. I could have also added a heading inside of here. Instead of using ARIA label, I could use ARIA label by. That would allow a screen reader user to jump to either the landmark or the heading. We have a button whose visible text is just a hamburger icon, which is meaningless for most users. So I override that with an ARIA label that says navigation. I tell it it controls an element of the ID of menu, which is that list. It has a pop-up. The pop-up is currently not expanded, and the button is not pressed. CSS, we can simply show the menu based on the state, mark expanded, etc. And our JavaScript is really, really simple. We just maintain the state of whether the menu is open, and then on click of the button, we invert that and set the appropriate expanded and pressed states. So to the screen reader user, this is how it looks. So this is VoiceOver on Mac. I can open the VoiceOver rotor, and I can see that the landmarks for this page were main navigation. So instantly, as the user, I can jump to the main navigation. I'm taken there, and then I press tab, and I'm told that I'm on a toggle button called navigation. If I press enter on that button, my menu opens, and then I can press tab, and I'm then told that I'm in a list of links. I can tab and shift tab back to these links. And then when I get back to the button, it tells me that my toggle button is selected, and that main actually contains two items because the menu is open and visible. If I press the button again, it collapses, and then I can tab away from that. So, responsive can introduce extra complexities. If your hamburger for your menu is only on mobile and changes to 768 or whatever, you would also need to set these states as well based on the breakpoints. But that's not too much of an issue. Another example is an add to cart. Pretty common pattern. As a sighted user, I can tell that that add to cart button is related to the Super Mario t-shirt and that it was successfully added to my cart. But if I couldn't see any of that, how would I know? Again, we start with good semantic HTML. Get a heading, Super Mario t-shirt, and a user can jump straight to that. They can then go to the thing next to it, which would be the button. And here we're using the visually hidden class. So the button text actually says add Super Mario t-shirt to the cart, but because the Super Mario t-shirt is visually hidden, a sighted user wouldn't see that because it's unnecessary noise for them. We have a toaster div, which is the green thing that comes down. We tell it's a role with an alert. And we say ARIA live equals assertive, which basically means when my contents change, try and alert me as soon as possible. So on click of a button, all we need to do is change the HTML in the toaster element to say that what's been added to the cart. Again, we use the same visually hidden span trick to say, put out the full text that the Super Mario t-shirt has been, and then leave the rest added to your cart just for sighted users. So this is how it looks. I tab onto the button, add Super Mario t-shirt to cart button. I press enter, the toaster comes down, Super Mario t-shirt has been added to your cart. Now it doesn't matter that there's a capital A in there, the screen is going to read that as normal. So with just a few simple little tweaks, we can begin to kind of define these relationships between elements and how they actually fit together. So hopefully you'll want to start thinking about, okay, how can I learn more? The W3C provides ARIA authoring practices, which describe in detail the code samples, the behaviors, the roles, and the states required for the majority of components that we use on the web. So that's a great resource. Aidan Pickering is big in the accessibility community. He's got some really good practical ARIA examples, and he's just created a new blog called Inclusive Components. Deck and OpenAjax has lots more examples. The code is very verbose, but it shows you what you need to do as well. I have a code pen collection, which includes a hamburger, add to cart, accessible tabs, accordions, and an autocomplete. Obviously, when you're starting out though, how do you know what to test for? So the W3C also maintains a tools list, where you can actually run multiple kind of automated tools on your site, and it will pick up various errors for you. The most popular are Wave and Axe, but there's lots more listed there as well. Obviously, automated tools aren't going to pick up every issue, so you need to be able to make sure you test yourself, and even better, include disabled people into your user testing. So, giving others that are less fortunate themselves the ability to enjoy the web as we do is just the correct and ethical thing to do. But in inclusive design, it benefits everyone. in the real world, ramps and elevators aren't only used by the disabled. Parents with prams use them because they make life easier. On the web, subtitles aren't only used by the deaf. And as they say, everyone is a keyboard user when they're eating lunch with their mouse hand. So hopefully I've shown that catering for accessibility isn't actually that hard, but you need to try and switch the way that you think about building things and try and identify the relationships and how things piece together if you weren't able to see them. And of course, practice makes perfect. I don't expect you to be an expert immediately, but I think you'll be pleasantly surprised by just with the small little changes you can make, what kind of impact you can have on people's lives just from the examples in this talk. And of course, you can't cater to everyone. The range of disabilities is huge. So we the 80-20 rule, as usual, try and cater for the majority of people. So the slides are all already up on slides.com. They're not mobile friendly, unfortunately. And all the links that I've linked to and resources I've mentioned are available. That's what it is. So thank you very much.
We have 5 minutes for questions, so who wants to be first? Okay, come on.
Thank you. I would like to ask who are the leading companies in accessibility?
So they're called the Cello Group, PACIELLO. They're kind of the main ones. DEC are another one. The accessibility community, like on Twitter and that, are really, really helpful. You can use the ARIA hashtag, and people will be very willing to assist you and stuff. I can give you other resources if you want to talk to them later.
Okay, thank you very much.
Okay, thank you. More questions from the audience? Oh, okay, I'm coming for you.
Do you think framework authors have a larger responsibility to ensure their frameworks are always accessible to users?
Yes. There's not enough education. The problem is when framework authors, they build these things and people just take them on, and us as normal developers don't realize that what we're using isn't accessible. So I think there needs to be a wider education program to make this more of a reality. So the next time the new React comes out or whatever, we need to kind of drill home that accessibility needs to be a first-class citizen.
Okay, more questions? Anyone? Okay, while we wait for somebody to volunteer a question, can you briefly talk about accessibility on mobile?
For native applications?
Yeah, or hybrid applications also. What's happening there?
So I haven't done any native mobile application stuff. I've done React Native things, which by default are kind of very inaccessible. It's like div sleep essentially for native. They do have lots of things you can add on, but it's real kind of overhead. None of that is baked in. But again, it's really on the developer to try and add this accessibility stuff in. If you were building a normal proper native application, you would use standard controls which have it built in.
First of all, thank you for that excellent presentation. I was tweeting like crazy. So to follow on from the last question, would you recommend, because I know it's all the craze, let's build our native apps in JavaScript, let's just throw them into Electron and we're done.
Yep.
And I'm seeing the same thing. And they're mostly entirely accessible, even on platforms that have excellent accessibility, like on Mac, for example. Would you actually recommend that people do this? Or, you know, just because you know JavaScript, is everything a nail?
Yeah, that's kind of the problem, isn't it? Using JavaScript is a skill that all of us have, so it looks really enticing to be able to do it. But yeah, to be able to do things properly, we need to actually understand what we're building. So native, if you use native script instead of React Native, that actually, the controls are more accessible out of the box. It actually is more native things. It's a tough one because people want to be able to build things and they don't want to be hampered by this, but they need to know that this is the real issue. I mean, if you were going to build something for mass market, I would probably err on the caution of using React Native and actually React Native.
Okay, lucky five. The lucky fifth question. Who wants to ask it? Okay.
Hello, thank you very much for your talk. I'd like to ask you if you know any good library to test accessibility, I mean, to do unit tests or integration tests.
Yeah, so Axe is a library which can actually now be integrated into like Mocha or things like that. So you can actually put it as part of your unit testing. So there's various parts of Axe. There's core and there's a browser plugin. There's all these other things that you just load as a JavaScript as well. So yeah, there are tools. If you look at that last tools list, you'll find some good ones there.
Okay, thank you very much, guys, for your questions. Thank you, Matt.